what do the inner planets have in common? Earth, Mercury, Venus, and Mars are more like each other than they are the outer planets. The inner planets are small and dense and have rocky surfaces. The inner planets are often called the terrestrial planets, from the Latin word terra, which means earth. In Spanish, tierra means land. Figure 1 summarizes data about the inner planets. The terrestrial planets all have relatively high densities. They are rich in rocky and metallic materials, including iron and silicon. Each has a solid surface. All except Mercury have atmospheres. What are the characteristics of the inner planets? Though the 4 inner planets have many features in common, they differ in size and composition as well as distance from the Sun. Mercury. Would you like to visit a place where the temperature can range from 430 degrees Celsius to below negative 100 degrees Celsius? Mercury is the smallest terrestrial planet and the planet closest to the Sun. Mercury is not much larger than Earth's moon. The interior of Mercury is probably made up mainly of the dense metal iron. Mercury's surface. As you can see in Figure 2, Mercury has flat plains and craters on its surface. Most of these craters formed early in the history of our solar system. Since Mercury has no water and not much atmosphere, the craters have not worn away over time. And those can be seen down here below. Remember those circular features that we see like on our moon, those are going to be different craters where meteoroids from space hit that surface and formed that cup or that pothole, as we called them. Mercury's atmosphere. Mercury has virtually no atmosphere. Because Mercury's mass is so small, its gravity is weak. Gas particles can escape easily into space. However, astronomers have detected small amounts of sodium and other gases around Mercury. During the day, the side of Mercury facing the Sun can reach temperatures of 430 degrees Celsius. Because there's so little atmosphere, the planet's heat escapes at night. Then the temperature drops below negative 170 degrees Celsius. Exploring Mercury. Much of what astronomers know about Mercury has come from space probes. Mariner 10 flew by Mercury 3 times in 1974 and 1975. Mercury Messenger has passed Mercury several times and will begin orbiting Mercury in 2011. Venus. Venus is so similar in size and mass to Earth that it's sometimes called Earth's twin. Venus's density and internal structure are similar to Earth's, but in other ways, Venus and Earth are very different. Venus has a thick atmosphere, an unusual pattern of rotation, and the hottest surface of any planet. Venus's atmosphere. Venus's atmosphere is so thick that it is always cloudy. As you can see in Figure 3, astronomers can see only a smooth cloud cover over Venus. The thick clouds are made mostly of droplets of sulfuric acid. At Venus's surface, you would quickly be crushed by the weight of its atmosphere. The pressure of Venus's atmosphere is 90 times greater than the pressure of Earth's atmosphere. You couldn't breathe on Venus because its atmosphere is mostly carbon dioxide. Let's go back up here really quickly to Figure 3, and this is the thick cloud cover that they talked about in our text. Venus's rotation. Venus takes about 7.5 months to revolve around the Sun. It takes 8 months for Venus to rotate once on its axis. Thus, Venus rotates so slowly that its day is longer than its year. Oddly, Venus rotates from east to west, the opposite direction from most other planets and moons. Astronomers hypothesize that this unusual rotation was caused by a very large object that struck Venus billions of years ago. Such a collision could have caused the planet to change its direction of rotation. Another hypothesis is that Venus's thick atmosphere could have somehow altered its rotation. A hot planet. Because Venus is closer to the sun than the Earth is, it receives more solar energy than Earth does. Much of this radiation is reflected by Venus's atmosphere. However, some of the radiation reaches the surface and is later given off as heat. The carbon dioxide in Venus's atmosphere traps heat so well that Venus has the hottest surface temperature of any planet. At 460 degrees Celsius, its average surface temperature is hot enough to melt lead. This trapping of heat by the atmosphere is called the greenhouse effect. Figure 4 shows how the greenhouse effect occurs. So down here in figure 4, that's solar energy. Penetrates through the atmosphere, hits the surface, and some of it escapes, but the majority of it is trapped so that it stays hot within that atmosphere. We feel the same thing in the 400 hallway. When you walk up and down our hallway, it's warmer than all of our classrooms or other areas of the school because we have those windows that let in that solar energy but trap some of that heat. Exploring Venus. The first probe to land on Venus's surface and send back data, Varanus 7, landed in 1970. It survived for only a few minutes because of the high temperatures and pressure. Later probes were more durable and sent images and data back to Earth. The Magellan probe reached Venus in 1990, carrying radar instruments. Radar works through clouds, so Magellan was able to map nearly the entire surface. The Magellan data confirmed that Venus is covered with rock. Venus's surface has more than 10,000 volcanoes. Lava flows from these volcanoes and have formed plains. More recent probes have included Venus Express from the European Space Agency, as well as a brief visit by space probes headed for other planets. Images from Venus Express have helped scientists understand how Venus's clouds form and change. Earth. There's only one planet in the solar system where you could live easily, Earth. Earth has liquid water and a suitable temperature range and atmosphere for living things to survive. The water planet. Earth is unique in our solar system in having liquid water on its surface. In fact, most of Earth's surface, about 70%, is covered with water. Earth's temperature. Scientists sometimes speak of Earth as having Goldilocks conditions. In other words, Earth is just right for life as we know it. Earth is not too hot and not too cold. If Earth were a little closer to the sun, it would be so hot that liquid water would evaporate. If it were a little further away and colder, water would always be solid ice. Earth's atmosphere. Earth has enough gravity to hold on to most gases. These gases make up Earth's atmosphere. Earth is the only planet with an atmosphere that is rich in oxygen. Oxygen makes up about 20% of Earth's atmosphere. Nearly all the rest is nitrogen, with small amounts of other gases such as argon, carbon dioxide, and water vapor. Like Venus, Earth experiences a greenhouse effect. Earth's atmosphere traps heat, though less than Venus's atmosphere does. Without the atmosphere, Earth would be much colder. Mars. Mars is called the red planet. Figure 6 shows why. This reddish color is due to the breakdown of iron-rich rocks, leaving a rusty dust behind. Though Mars is too cold for liquid water, it does have water ice now and had liquid water in the past. Mars's atmosphere. The atmosphere of Mars is more than 95% carbon dioxide. You could walk around on Mars, but you would have to wear an airtight suit and carry your own oxygen. Mars has few clouds, and they're very thin compared to the clouds on Earth. Temperatures on the surface range from negative 140 degrees Celsius to 20 degrees Celsius. water, and ice. Images of Mars taken from space show a variety of features that look as if it were made by ancient streams, lakes, or floods. Scientists think that liquid water flowed on Mars' surface in the distant past. Scientists infer that Mars must have been much warmer and had a thicker atmosphere at that time. Today, Mars' atmosphere is so thin that any liquid water would quickly turn into a gas. So, where's Mars water now? Some is located in the planet's two polar ice caps. Scientists thought that the ice caps contained frozen carbon dioxide, but recent data show that the caps are almost entirely made of frozen water. Observations from the space probes Mars Global Surveyor and Mars Reconnaissance Orbiter have found large ice deposits just under the surface. Volcanoes. Some regions of Mars have giant volcanoes. There are signs that lava flowed from the volcanoes in the past, but the volcanoes are rarely active today. Olympus Mons, shown in Figure 7, is the largest volcano in the solar system. It is as large as Missouri and is nearly 3 times as tall as Mount Everest. Mars's moons. Mars has 2 very small moons. Phobos, the larger moon, is about 22 kilometers across. Deimos is even smaller, about 13 kilometers across. Like Earth's moon, Phobos and Deimos are covered with craters. Exploring Mars. Many space probes have visited Mars. Recent missions have focused on finding signs of water and possible life on Mars. Rovers called Spirit and Opportunity found traces of salts and minerals that form in the presence of water. The Phoenix mission took samples of soil and found frozen water near the North Polar Cap. Orbiting spacecraft such as the Mars Express have detected methane gas in Mars's atmosphere. This gas might be a clue that microscopic life forms exist on Mars even today.